طيب بسم الله الرحمن الرحيم. So last time we started to talk about host routing. Why am I? So we talked about host routing, and we talked about three types of routes: the loopback routes, the local network route, and the remote network route. So today, inshallah, we're going to talk about how the router, the routes inside the host routing table get activated or get selected based on certain destination address. So typically the host would receive a packet with a destination IP. Okay. So what the host needs to do now is to decide based on this destination IP which route of these in the table that it should select and route this packet accordingly based on these lines. So what happens is that this destination IP, let's have an example. So let's say the destination IP address is 127.0.0.1. So this is clearly loopback address, as we have discussed last time. So the loopback address should stay in the host and never exit any interface. Okay, never exit the host interface. So we need to know based on this destination address which of these lines will be selected. Okay, so first the rule or the procedure is first use the net mask column, okay, to get all lines matching, which means potentially is that based on this address there might be multiple of these lines matching. Okay, so for example, if we use the destination address 127, what will happen is that we will use the net mask, okay, and try to apply the net mask to this address. Of course, these addresses are by default binary. Okay, so I assume that you can convert 127 to binary and 0 to binary and so on. So the conversion is very easy, but very straightforward. We need to apply the mask, this mask, to this address. So we'll apply first mask, which is 0.0.0.0, and then we do an AND operation. Okay, if the result of the AND operation matches the destination network address, then this line matches. Okay, so clearly if we do AND operation, anything that's ANDed with 0, the result will be 0, which means that the result will be 0.0.0.0 all the time. And this means that line 1 always matches anything. Okay, we call that a default route. Okay, but if we take the same destination address and we try to apply the second net mask, which in that case 255.0.0.0, right? And then if the result matches this one, this means that line 1 also matches, line 2 as the also matches. So in that case, if we put 255 is 8 ones. 255 is 8 ones in binary. So anything ended with 1 is anything, is x. X ended with 1 is x. So 127 ended with 255 would lead to 127. So the result would be 127, and anything ended with 0 is always 0. So the result will be 127.0.0.0. Okay, which also matches this one. Okay, which means that line 2 also matches. This means that we can potentially have more than one line that match. Okay, so this is number 1. Number 2, or step number 2, select the line with maximum number of ones in net mask. Okay, so select the line or the lines, by the way, there could be also multiple lines, which means that for this particular destination address, okay, if we try to do a match with line number 1, it matches because anything ended with 0 is 0. If we try to end it with this, the result will be 127. If we try to end it with this one, which is 255.255, which means all ones, okay? So the address will stay the same, which means 127.0.0.1, which also matches this one, okay? Which means that line 1, line 2, line 3, all of them match. So which one do we select in that case? We will look in the net mask address. We will find the line that has the maximum number of ones, which in that case is line 3. And we select that line for routing, which means that this line will be activated if the destination IP address is 127.0.0.1. So this line indicates that the packet will stay on link and the interface is loop back, which means that it will not exit the host interface aslan. So 127.0.0.0 in the interface, meaning that the packet will stay inside the host and not exit the output interface of that host. So that's the procedure. Number 3, which would not happen in our case, if we still have more than one line, we select the one with minimum metric. Remember, we said in the previous lecture, we said that there is a column here called metric, and we said that the metric indicates the cost I have to pay in order to go through that route, and it indicates roughly the distance between me and the final destination. If I want to go to QU, okay, I need to go through QU. I need to go to QU, maybe potentially using multiple routes. So which one will have the shortest distance or the fastest route to QU? So that depends on the metric. Of course, the metric column in that exercise has been omitted, in which case number 3 will not apply in our case. So having said that, we need to go through this exercise and say, if we need to ping this IP address, okay, so we need to apply that procedure and say, okay, so which lines match and which line will be selected, which lines match first and which of them that will be selected. So the lines that match will potentially be multiple lines. So for example, line 1 here matches all the time, so I don't have to perform any matching for line 1. I know that line 1 is always an option, okay? So if we try this destination IP address, so line 1 matches, okay? Line 2, if we end the 127.1.1.4 with 255.0.0.0, the answer will be 127.0.0.0, right? Which means that line 2 also matches. Line 3 requires exact match. So there has to be an exact match between this address and the destination address. And in that case, this exact match does not exist. So the two addresses do not match, okay? So only line 1 and line 2, they match. If you try the same thing on all the other lines, they don't match. Hussam, do you have a question? Tfaddal. Matching means that we need to take that destination IP address and it with the net mask, and so 127.0.0.1 ended with 0.0.0.0. You have to convert both of them to binary because AND operation is done for binary, okay? So, but يعني أنا I did this fast because I know how we end anything with zero. Anything ended with zero is إيه يا حسام؟ It's zero, right? So the result will be 0.0.0.0. That's why it's called mask. Mask means that we need to focus on certain part of the address from the left-hand side. The first byte should match, or that first 2 bytes should match, or the first 3 bytes should match, or all the 4 bytes should match. Okay? So if I require no byte to be matching, which is the case for line 1, so line 1 always matches, right? Line 2 requires the first byte only to match. Only the first byte from the left-hand side, which is 127. And here it's 127. So line 2 also matches. Line 3 requires all the 4 bytes to match, right? Because it's 255, the 255, the 255, the 255, which means all of them are ones. 32 ones. That's how the net mask is put here. So in that case, we require all the 4 bytes to match. So if you compare this address, 127.1.1.4, and this address, 127.0.0.1, do they have exact match? Of course not. So in that case, line 3 does not match. واضح كده? So if we have 2 lines, then we look at the network mask for these 2 lines, and we select the one with the maximum number of ones, which in that case is line A, line 2. واضح كده؟ So, so the second question here, command to ping default gateway. That's a tricky question. I did not even give you the destination address. So the most important thing is to get the destination address. So what is the destination address for the default gateway? Anyone knows? What is the destination address for the default gateway? The IP address for the default gateway. I didn't give that to you. 10.1, yes, which is this one, because this one is the gateway column. And if the gateway column has an IP address, this means that this is the IP address of the default gateway. Otherwise, it should be on link. واضح كده? So the default gateway has an address of 192.168.10.1. So this is the destination IP address that I want to find a match for. So without doing any operation, line 1 matches. Okay, so we don't have to do anything regarding that. So if we look at, of course, line 2, line 3, line 4, they don't match. Line 5 here, if we look at line 5, we find that line 5 requires matching of the first 3 bytes. And the first 3 bytes here are 192.168.10. Yes, there is a match. So line 5 matches. Okay? How about line 6? Line 6 requires all the 4 bytes to match. And the last byte here is 10. But the last byte that we have here is 1. So there is no match. So line 6 will not match. Okay? So here I have line 1 and line 5. And obviously I select the one with the maximum number of ones in the subnet mask, which in that case is 5. واضح كده يا شباب؟ طيب. Number 3, we send to a host with the IP address of 10.10. Okay? So very fast. Yeah, so very fast. If you find an exact match, that will be the one that you select right away. So we have an exact match here. Just to speed up the calculations, we have an exact match here. And this requires all the 4 bytes to match, which in that case is 6. طيب. Command to send to a host 192.160. Oh, okay. So you need to pay attention to the values here. If you don't pay attention to the fact that this is 160 and our network has 168, then you lose the grade for no reason. So 160 here, what is the match? Which line that matches? If you try to match it with line 5, line 5 requires 3 bytes matching. There's no 3 bytes matching here because this is 160, not 168. Okay, line 6, no match. Line 7, no match. Line 8, of course, to 11, no match. So which one will be selected? Line 1. Line 1 always matches. Okay? Right. So command to send to 192.168.255.255. Of course, there's no exact match. Let me just, there's no exact match. And here, if we look 192.168.255.255, this one will not work. This one will not work. This one will not work, and nothing works. So again, the default route will be valid in that case. And of course, command to send to IP 127.0.0.0. We did that one already because it matches with 1 and 2 and 3, line 1 and 2 and 3. And of course, in that case, we will have the one with the exact match, which in that case, line 3. ماشي كده يا شباب? Any question here? So, sorry? Part 3 or question number 3.3, right here. Okay. Yes, if we still have, yes, if you find that there are two lines match and the number of ones, like for example these two lines, for example, okay, the number of ones in the network mask is the same. We said that we select the one with the maximum number of ones, but there are still two routes with the same number of ones in the network mask. Okay, which one do you select? So in that case, if the number of ones in the subnet mask are the same, then and only then you go to the metric. You select the one with the minimum cost, with the minimum value in the metric column. Okay. But of course, as I said, number 3 does not apply in this particular exercise because the metric column has been omitted altogether, right? Okay, so this activity here talks about the host routing table for IP version 6. Okay, so we'll start to talk about IP version 6. Of course, we talked about the limitations for IP version 4 that led to the standardization of IP version 6. And as we know, the most important differentiation in IP version 6 is that the IP address itself has a size of 128 bits. 128 bits. Okay, that's clear in this column. Okay, so the IP version 6 itself exists in this column to indicate the destination network, which is similar to the case for IP version 4. So this column indicates all the reachable networks. Okay. However, we see here some differentiation. Of course, in order to see a full IP address version 6, this is what the IP address version 6 looks like. This is in fact 128-bit address. Of course, it's represented using hexadecimal, and hexadecimal separated by a colon, not a dot in that case. We call it colon hexadecimal notation. Okay, so unlike IP version 4, which is represented using dot decimal notation, this is colon hexadecimal notation. And the reason for hexadecimal, of course, is that hexadecimal is 4 binary numbers, so we can sort of, compress the representation of IP version 6. Okay, we will talk about this in details in the next chapter, but for now, this is how the reachable network could look like. And one difference here is that this column combines two columns from the previous host routing table, because this slash, okay, slash number here, this slash number here indicates that this is actually the net mask. So for IP version 6, if you display the routing table for the host, which you can do using netstat/d or something, so you see that the reachable networks, it actually combines two columns, the reachable network IP address and the network mask. So this is an abbreviated way to represent the subnet mask. So instead of having 255.0.0.0, so if the network mask is 255.0.0.0, .0.0, okay, the network mask, we find that the network mask always, all the time, has to have consecutive ones, which is, in that case, 255 is 8 ones, right? And then the rest is 0, right? You always have consecutive ones and then consecutive zeros. You never have 1 0 1. You never have this. That's why it's called mask. Mask معناها it masks the first n bits. Okay. So they said, okay, so instead of using 255.0.0, we can say this /8, and 8 here refers to the number of ones, because the rest, okay, which in that case 24 bits, the remaining bits for the IP address is 0. So instead of saying 255.0.0.0, we can simply say /8, which means that /32 here means that we have 32 bits ones, and the remaining bits up to 128 bits are 0. We know that. If we say /0 here, this refers to the default, again, the default route. And this means that all the 128 bits are 0. And that's a valid network mask, okay? And of course, 128 here means that all the network mask, it requires exact match, which means all the 128 bits are ones. واضح كده? So this means 64 ones, and so on. So the first difference here is that this column combines two things. This column here combines the address, and we will talk about how we can abbreviate the IP version 6 address. This is an abbreviation of IP version 6 address. We'll talk about that in the next chapter. And the network mask. Luckily here, we don't have to do the matching exercise for IP version 6 because it's a bit tricky. It's not very tricky, but we don't have to go through it. Okay? So what we need to discuss here is, in fact, the definition of each column and what it means. That's all what we need to know at this point. Okay? So this column, as we said, it combines the reachable networks and the network mask. We talked about this. This column is the metric, which means the cost for reaching to the destination through that particular route. And the less, the better, which means that 58 is better than 306. Okay? So the metric here represents the cost, okay, to reach to the final destination through that particular route. Okay? طيب, this IF column is by the interface. And the interface here, unlike the host routing, which uses the address, the IP address of the interface, here we don't use the IP address, we use the interface number. We use the interface number. And IP version 6, again, unlike IP version 4, it combines multiple access technologies in the same routing table. Okay, so the interface 1 indicates usually loopback, which is the one related to the fact that the packet will not exit the host, will stay inside the host. 16 here refers to, for example, Ethernet, because the host or a laptop, imagine a laptop typically would have Ethernet cable and would have Wi-Fi, right? So we very commonly have our laptops have two different access technologies that both of them are considered exit interfaces. So the packet may exit through Wi-Fi or may exit through Ethernet. Okay, so 15 here refers to Wi-Fi. So IP version 6, again, is designed based on the lessons learned from IP version 4. IP version 4 displays separate routing table for each interface. So Wi-Fi will have a routing table, Ethernet will have a separate routing table, and so on. IP version 6 said, okay, so we can combine all of these in one routing table, and we can still do that, which is more efficient. Okay, so that's a big differentiation between IP version 6 host routing table and IP version 4 host routing table is that the interface is represented using a number or an ID to refer to the access technology or loopback which we have. And the gateway is actually the same column like the gateway. Here there is a typo here because this default route should in fact have the IP address of the default gateway here, right? Because this is the default route. But here in this table, strangely enough, it's not put, and I think this is a typo. Otherwise, the packet stays within the network or inside the host in the case of loopback. واضح كده؟ So these are the definitions for the different column A, B, C, and D. That's all we need to know about IP version 6. We don't have to match the route or to match the lines similar to IP version 4. We don't have to do that. So having said this, which of these columns indicate the Wi-Fi, Ethernet, or other network-capable interfaces? Which line here? A. واضح. So the route cost, lower numbers are best. So this is A. B. So the reachable network available. This is واضح. C. Okay. The network address is found in this column. Same thing. C. And the address used to send to a remote network. The address used to send to a remote network. This is the gateway address. Okay, which is in that case D. Okay. Type. So the next topic here is router routing. So we are done with the host routing, and now we need to talk about router routing. So router routing is much more complex. So the way that the routers routes packets is much more complex compared to host routing. The host, as we said, if the host wants to send a packet to an outside the LAN يعني, it will send it to the default gateway. The default gateway will trigger now the router routing. Okay, the default gateway is a router, and this router will have to trigger the router routing. So first we need to talk about what are the classification or the major categories for router routing, what are the possible routing mechanisms, and then what are the types of the routes used by the router. So logically, we have a router, right? And the router, unlike the host, the router may have multiple interfaces, not just one or two. It may have actually multiple interfaces. Each interface is connected typically using either a LAN, like Ethernet, in that case, or Wi-Fi, doesn't matter. Here, I'm just drawing the logical topology. Either a LAN using Ethernet or hubs or Wi-Fi or something like this. So there is a LAN here. There's also a LAN here. Maybe using, in that case, fiber optics or something like this. And there is another LAN here, okay? And it may have a LAN here, and this LAN is also connected with another router, okay? And this router is connected maybe with a serial point-to-point link to another router, okay? So let's say this is a router 1, this is the router 2, and this is router 3, okay? Router 2 has also some LANs. Router 3 has also some LANs, okay? So the router 1 is the one that we need to focus on now. Router 1 now needs to know how to route packets based on the destination address. So we need to know two things. If I want to route a packet with a specific destination IP, okay, first, which exit interface I should send the packet through? Which exit interface I should send the packet through? In that case, here the router may have multiple exit interfaces, exit doors يعني. Okay? And then when I exit through one of these exit doors, okay, the packet will go technically through this LAN or the serial point-to-point. So it will either go through one serial point-to-point link, okay, which means we activate PPP protocol, for example, or it goes through this interface, which will go through Ethernet, or maybe here, which will go technically مثلا through Wi-Fi, and so on. Okay. So this is the first question: which exit interface or which exit door I should send a packet through? Okay, this is packet forwarding. And the second question is the packet supposed to be sent to this LAN, or I should engage this router, okay, to send the packet further through one of these remote routes, or maybe here. Okay. So that's the second part of the question. First, I should exit the packet through one of the exit doors, and second, should I engage router 2 or router 3 to send the packet further, or the packet should stay on the LAN that this exit door is connected to? Okay, so in that case, the router has two types of routes. Two types of routes only, not three بقى like the host, because there's no loop back for router. There's no loop back for router. So the router has two types. Either the red routes, which we call them directly connected routes. Okay. So this is the first type. So the directly connected routes are physically connected with the router on one of the interfaces of the router. And in that case, the router would learn about these directly connected routes directly without having to get any information from anyone. Once the router starts, all these interfaces are activated. Each interface, by the way, from the physical layer, it knows that this is Ethernet, this is PPP, this is Wi-Fi. Okay, so all the red routes will by default be learned by router 1. Router 1 doesn't need anything other than just activating these interfaces to know the directly connected routes. Okay. Number 2 بقى, and this is the tricky one, is the remote routes. So the remote routes هنا بقى, router 1 does not know the blue routes by default. This is the problem now. Router 1 needs to learn about these blue routes. For example, if I need to send a packet to like QU, router 1 needs to say, oh, okay, I know if I want to send this packet or this card to QU, I should go through router 2. And router 2 should be able to send this card to QU in the fastest way possible. However, if I want to send this car to Al-Dukhan مثلا, then I need to go probably to router 3, because I know that router 3 would deliver this car faster to Al-Dukhan region or something. واضح كده؟ But router 1 initially does not have this knowledge. Does not know that if I want to go to QU, I need to go through router 2, and if I want to go to Dukhan, I need to go through router 3. So router 1 needs to activate a routing protocol or routing mechanism to learn about these blue ones. So there are two categories of routing mechanisms or routing protocols that we have in this topic. So what are these two categories of routing mechanisms, and what is the difference between them? حد عارف؟ Anyone? What are the types of routing mechanisms or routing protocols that I can use? Any raise of hand? I hope next week we'll switch to face-to-face classes so that we can interact more. اتفضل يوسف. ايوه برافو عليك. static routing تمام and dynamic routing. ماشي يا يوسف. طب what is the difference between them يا يوسف؟ any idea about the difference between them؟ static معناها ايه؟ لا اتفضل. طيب ماشي. Static here means that if I want to have router 1 learn about these new routes, the network analyst or the network operator should log on to this router and manually insert in the routing table of R1 all these blue routes manually. He will have to enter it manually. Okay? And this means that these routes for R1 will be learned manually and inserted in the routing table manually. So what is the implication of this? The implication of this is that, of course, as we all know, human beings are prone to errors if the network analyst, for whatever reason, and that's why we need to teach bright people like you to not get into these easy mistakes. If that network analyst enters manually one of these routes incorrectly, okay, what will be the implication? The implication is that this router would route packets incorrectly, which may potentially lead to packet loops, and maybe the cars will get to a construction site and maybe will hit the construction. Some damages might happen in the network. Okay, so static routing may be feasible if you have like if you have a network of 2 routers, very small network. Okay, because imagine if my network has 100 routers, can you imagine the network analyst would log on to each individual router and from each individual router inserts manually all the routes of the other routers? Of course it's not feasible, it's impossible. Okay, so if we have 2 routers, we could do that. Like for this graph, the network analyst may log on to router 1 and he can insert these blue routes manually, maybe 2 or 3 or 4, doesn't matter. So we can potentially do that. But imagine if I have 100 routers, it's not possible. So imagine also if I have like 4 routers, meshi, and the network analyst would log on to each one and would insert manually these routes in the routing table of each router. And all of a sudden, one Ethernet LAN goes down or one router goes down. Okay? And maybe after 2 minutes, it goes up again. So in that case, the network analyst should, every minute tries to remove the route from the routing table or insert routes in the routing table. It's not feasible. Okay. So if the network has some dynamics, some routers goes up and down, or if the network is too large, okay, static routing becomes a really problematic way of inserting routes inside the routing table. So we cannot afford this. So that's why we have dynamic routing. And dynamic routing, we have to start one of the dynamic routing protocols. We have plenty of them. So we have, like, for example, we have RIP, or Routing Information Protocol, or we have OSPF, or we have IGRP. So these are dynamic routing protocols. So static routing is just one, static routing, that's it. Dynamic routing protocol, we could possibly have multiple of them. Alice? Yes, ma'am, that's what we're saying. So OSPF, RIP, IGRP, all of them are dynamic routing protocols. Okay, so these are dynamic routing. And what dynamic routing protocol mean is that all the network analyst needs to do is to say, start RIP on the router, and his job is done. He doesn't have to insert anything manually now. These dynamic routing protocols would allow the routers to exchange some messages to learn about the routes of each other. For example, these blue routes for R2 are directly connected. So R2 would send information about these directly connected ones to R1. R3 would do the same. R1 now will have to consolidate. So when R1 tries to consolidate, R1 will learn that if I want to send to QU, I need to go to R2. If I want to send to Dukhan, I need to go to R3, and so on. So this has to happen through one of these routing protocols. In Network 2, for those of you who will go through Network 2, we will talk about these routing protocols in details. Okay, maybe 1/3 of the course is focused on this. Luckily, here in this course, we just need to know the difference between static routing and dynamic routing. And in dynamic routing, we just learn about these examples. We don't need to know the details. Okay, كده? So having said that, we know the difference now between static routing and dynamic routing. So now we'll go back to these columns بقى. So the router routing table بقى looks somewhat different from host routing and from IP version 6 host routing tables. So this column A, indicates how the route has been learned. Okay, whether it's S for static, D for let's say IGRP, okay, O for OSPF, or R for RIP, and so on. Okay, which technically means I could have in the same router, I could start RIP and OSPF. There's no restriction. You can start multiple dynamic routing protocols. So these dynamic routing protocols will try to learn all the routes of the network, and then it will start to insert some route entries in the routing table. Okay? طيب. So that's column number 1. Column number 2, again, is similar to IPv6 6. We combine the reachable network with the net mask, which in that case is abbreviated. Column number 3, again, is combined. So this 3072, this is the metric. So we know this is the metric. واضح كده؟ So we know this is the metric. 90, this 90 بقى حد عارف دي indicates what? Indicates something called administrative distance. The administrative distance indicates the trustworthiness. احفظ الكلمة دي. The trustworthiness of this route. How much I should trust this route. And what that means is that now, as we said in the previous procedure, if we have multiple lines that match, we select the one with the maximum number of ones in the network mask. We did that. And the result is there are 3 lines that still match with the same number of ones in the network mask. Okay? In that case, most probably, these 3 lines are in fact inserted in the routing table by 3 different routing protocols. Maybe one is inserted by static, one is inserted by IGRP, and one is inserted by OSPF. Okay, so the one route which allows us to go to QU has been inserted manually by the network analyst, and it's a static. And another route which allows us to go to QU also, okay, and it's inserted by IGRP, and another one by OSPF. So which one do we select? So in that case, you should identify the one with the minimum administrative distance first. Which one should we trust? And again, the administrative distance, the less, the better, similar to the cost. So the network analyst or the network operator should assign an administrative distance to each routing protocol. Usually, the static routing protocol مثلا would have 80 to indicate that if we have a manual entry, this is the one that we should trust. OSPF maybe 110 مثلا, so 110 to indicate that yeah, we can trust it, but with a value of 110. And IGRP maybe 90. Okay, so if we have 3 routes with the same number of ones in the network mask, one is S, one is D, one is O. Which one do we select? We select S. We select the static route because the static route has less value in the administrative distance. So administrative distance measures the trustworthiness of that route. If it happens then that we learn two routes to QU through the same routing protocol, which means it has the same administrative distance, then we select the one with the minimum cost or the minimum metric. واضح كده يا شباب؟ طيب, so D here is similar to the gateway, and the gateway, we don't call it that gateway for the case of router, we call it next hub. Because remember, here the router does not have a default gateway. The router itself is the default gateway, but the router has many next hub points that it can send the packet through. So in that case, I could send it through R2, which means that in that case, this IP address indicates the IP address of this port. Or here, okay, so I could have many next hub points. So in that case, we call it next hub. واضح كده? This indicates the interface. This indicates the interface. And here the interface, instead of using IP address, we use again an identifier, similar to IPv6, but here the identifier we use names. So this gigabit Ethernet indicates that this is in fact an Ethernet LAN, okay? And if you have multiple Ethernet LANs, then we use 0/1 or 0/0 or 1/0 or something like this to indicate the different gigabit Ethernets. Last is this, which measures the freshness of the route. The freshness of the route. So the less time here, this is called elapsed time. The less time here, this means that this route is fresh, similar to the caching mechanism. Okay, so this route is fresh, and in that case, I can make sure that this route is valid and it's reliable, so I can use it. واضح كده يا شباب؟ So very quickly بقى, what is the elapsed time? What's the elapsed time since the network was discovered? So which line is this, or which column is this? The elapsed time is column E, bravo. Yes. The administrative distance and the metric combined. This is واضح. This is C. How the network was learned by the router. This is A. تمام. Shows the destination network. This is B. The next hub IP address. The next hub IP address, which is the gateway, which is D. And the outgoing interface, which is F, the last one. واضح كده يا شباب? Any question about this? Okay, so we'll just activate the check-in now.